All right, we're back with Math 676, and the topic of this lecture is going to be integrated development environments. So this is, in particular, I'm going to talk about a program called Eclipse. And before I start this, so this is a topic that's really dear to my heart. I would like to talk about, let's say, a personal perspective on this. So when I started programming in 1987, the thing that was around at the time was just MS-DOS. That was very basic. It was a text-based environment, and there was nothing much in terms of support for programming. You would write programs in an editor that was called Edlin, so you would write essentially one line after the other. And then in 1991, I got hold of a program that's called Emacs. At the time, it ran on an operating system that's called OS/2 that has long been forgotten, unfortunately, because it was far ahead of its time. And to me, Emacs was a revelation. I think a lot of us who use Emacs or who used Emacs for a long time feel like it is the best thing since the invention of the wheel. And people, surprisingly, feel really very religious almost about the choice of editor that they have. So I used Emacs for the next 20 years, and I tried to teach my students how to use Emacs, and that worked reasonably well for the first few years when I taught this course. I taught this course in 2006 and 2008, and I could still teach my students to do this. And then in 2010, I realized my students don't want to learn this anymore. And the reason, of course, is that in the meantime, people have grown up programming with editors that are graphic, where you can use your mouse, where you use buttons, and so on and so forth. And Emacs does not have any of this. Emacs is essentially a text-based interface. The advantage of Emacs is that it can do anything that you want. Emacs is essentially an operating system. It has all sorts of modes. It can edit text files. It can edit C++ files. It understands part of this. And it can indent things. It can color comments in a different color than it would color, let's say, keywords or variables, and so on and so forth. So for a while, Emacs really seemed like the tool to use. But as I say, it's not graphical. And so over time, when I realized that I can't teach my students this anymore, I realized that I need to explore other options too. There's probably a good reason why these students don't want to learn it. So I started to explore what's around. And in 2010, there were a number of programs. I started to use a program that is called kdevelop, which was really good for that purpose. And 2 years later, I tried something that I had heard quite frequently about, a program that's called Eclipse. Eclipse is what we call an integrated development environment. So the difference between an editor and an integrated development environment is essentially that an editor just looks at a single file, or maybe just at individual lines of code, whereas an integrated development environment tries to take a view of the entire project all at once. And it turns out that it can help you so much more than what Emacs can do, or what any other editor can do. So there's really a huge difference between an editor and an integrated development environment. And so what I would like to show you today is a little bit how to use Eclipse. So to me, as I say, Eclipse was the second revelation. The first one was to learn Emacs. The second one was to learn Eclipse, because suddenly programming has become so much more fun again. I find myself to be so much more productive when I program in Eclipse. There's I don't have to type as much. I make far fewer mistakes. There is support for all sorts of information that I always sort of knew was out there, and that usually was just in my brain, but now it's at my fingertips on my keyboard. And I want to show you a little bit how to set up Eclipse for projects based on deal.II, and how to use it for that. So let me walk you through a few of the arguments for an integrated environment. Like I said, I'm a long-term 20-year Emacs user. Other people oftentimes use a program that is called VI, or any of the versions of it, for example, Vim or GVim, which is, let's say, an even more basic version of Emacs. It's surprising. I really don't understand why people use VI, but the VI camp is as religious about VI as the Emacs camp is about Emacs. So there are a number of other editors that people use, but these are, let's say, the ones that have traditionally been used for programming under Unix or under Linux. Now, one of the things that's worth keeping in mind when you think about these sort of tools is that just because we know a tool very well, just because we have used it for 20 years, does not really mean that it's the best tool that's around today. So many times these tools that we know and that we use them because we've used them for a long time, and we just don't take the time to learn something that might actually be better suitable for the task. So I think one of the things that I learned in the context of thinking about Emacs is that, or thinking about Emacs and Eclipse, is that one of the things that you really have to take into account from being a graduate student to being a professional is that the one thing that you have the least of is your own time, is your programming time. Your CPU time does not matter. It doesn't cost that much to buy a faster computer. It doesn't cost that much to buy a computer with more memory, for example. But it is not possible to buy a second U. So the time that you spend programming, the time that you spend developing your own software, that is the one resource that cannot be replaced or extended. So to me, I think that whole episode showed really that I need to keep learning new tools. And so if you are an Emacs or a VI user, I really implore you to explore new tools like Eclipse, or if you use some old-fashioned visualization program, you need to explore newer visualization programs that might make this process simpler or faster. That's sort of going to be one of the themes that I have going through the tools that I'm going to look at in this class. So I have today the lecture on Eclipse. There is going to be a lecture on current visualization programs. There is going to be lectures on documentation tools, and so on and so forth. And the goal always is to achieve the maximum result with modern tools, because they're just faster, better than what we may have learned 10 or 20 years ago. Okay, so as I said, VI and Emacs, for example, they are certainly good editors, but they're not integrated environments. And in particular, they're text-based and not graphical. So today, I think most of my students, for sure, people who are a few years younger than I, have grown up with graphical tools and want to use that. And I think for good reasons, actually. I think in many cases, I can still make an argument that I'm faster on the keyboard than they are with their mouse. But there are tasks that are just so much easier if you do them with a graphical environment. And neither VI nor Emacs nor many of the other traditional editors have that. Eclipse is not the only tool. It's the one that I have learned to like, that I'm going to talk about today. There are other tools like Kdevelop, like Xcode under Mac OS. If you're a Windows programmer, the Microsoft Visual C++ is certainly another option. There are a number of other smaller projects, but I think Eclipse, Xcode, and Microsoft Visual C, C++ are the three big ones. And so there is a good reason to use these. Now, here's a few examples of something that an IDE, an integrated development environment, can do for you, as opposed to an editor. The primary thing that these tools do is they know about the code. An editor reads a file, a single file, and it may look at the context of an individual line. But an IDE has so many more tools and reads so much more information that it can present to you. For example, when you declare a variable somewhere in your program, let's say it's declared in a header file, and you use it in a source file, the IDE will know what the type of that variable is, and it will be able to offer you what you can do with it. So let's say you're a C++ programmer. Let's say this variable, for example, is a class type. Then if you use this variable in one of your functions and you write the object dot, and then the IDE can automatically offer you what member functions this object has and that you can call at this point. So that's the sort of thing that an IDE can do. Then you can rename variables, because the IDEs really understand your code. It knows, for example, that if you want to rename a variable in one function, let's say it's a local variable in a function, you want to rename this at the point where it's declared, it's going to change all of the occurrences of that variable name further down in the function. What it's not going to rename is a variable that happens to have the same name but lives in a different function. Okay, so it doesn't just replace all occurrences of one particular text string by another string, but it's actually going to look at the context where the string occurs, and it knows that this is a variable name, and it knows where that variable lives, namely in this function and not in another function. Other things it can do is, let's say what you often do when you develop code is that you have a function and it has, let's say, 2 arguments, and you realize it really needs to have a third argument. Then in C or C++, you always have this slightly awkward situation that you have the declaration in a header file, and you have the implementation in an implementation file, in a .cc file or .cpp or whatever your convention is. So typically, when that happens, you have to change 2 places. And that's always bothersome, because that's always a potential for error if you have to change 2 places. And so these IDEs, because they know that the declaration here matches the implementation over there, you can do things like you edit it only once, and it automatically updates the other place for you. Other things that I'm going to show you is when you write a function, let's say you call function ABC, and you write opening parentheses, then because the IDE can look up what that function ABC is and what its argument list is, it can automatically give you hints at, let's say, how many arguments there are, what the types of the arguments are, and so on and so forth. So all of these sort of things are meant to make you a faster programmer, because it can give you hints. You don't have to look up stuff as often. You don't have to do trial and error as often. Oftentimes, let's say, before this, we would compile our code and realize that, I misspelled this function name. And the compiler would complain, and we would have to go back and fix the function name. This is, in big projects, a real problem, because it takes minutes to compile a big project. You've seen this with deal.II, for example. If you had only a single processor, it would take about an hour to compile. And if you make these sort of mistakes, it might take several minutes until the compiler finally gets to the file where you had that mistake in. And then you have to go back and make a 2-character change because you misspelled the name, and do it all over again. So that is something that's just avoidable, and the IDEs help you with this because they know how function names are spelled. So typically what you would write is, I'm going to show this to you later, instead of writing the function name execute coarsening and refinement out every character by character, you would just type, for example, EX, and then let the IDE autocomplete this. So there's no potential for mistakes anymore in this. Okay, so about Eclipse. Eclipse is is probably the largest and most widely used IDE. If you go to the web page that I have at the bottom of this page here, eclipse.org, they offer you to download this, and you can see that it's downloaded millions of times for every release. It is open source. It is cross-platform. It runs on basically every device, from a laptop to a supercomputer to a cell phone. It is developed with an interesting model. While it's open source, I think we often think of open source as something that is, let's say, volunteer-driven, something where you have a relatively small number of volunteers who develop something, let's say, like Linux or maybe Emacs itself. Eclipse, by and large, is developed by professionals who are paid by companies for this. And it is built by a consortium of companies that includes basically every big company in the software business: IBM, Novell, Oracle, SAP. All of these companies have developers that help with the development of Eclipse because they have realized that there's no point in developing their own tools, every company their own tool. It is much more useful if they all contribute to one tool that everybody can use. Eclipse is a framework, essentially, that allows you to put plugins into the system. So, for example, the support for C and C++ is something that doesn't actually happen in the core of Eclipse, but there's a plugin that is called the C and C++ tool development. I forgot how exactly it's called. I have it on one of the next slides. But there are hundreds of other plugins. So if you want to draw, let's say, a UML diagram of how your code works, or if you want to have documentation, there are plugins for all of these sort of things. And the if you can go to the Eclipse website and download all of these things. Okay, so like I said, you can download Eclipse from eclipse.org. You can download the C and C++ development tools, CDT, from Eclipse as well. There's even today a prepackaged version of Eclipse that already has this built in. And I'm going to show you a little bit about how to use this. So let me go into this directory where I have installed deal.II. That's the same place as we had it yesterday, and I would like to go into the step 1 directory that we had looked at. So this is the pristine state. All of these tutorial programs are essentially self-contained projects. They happen to be in the directory examples of the deal.II distribution, but you can copy them wherever you want. I'm just going to work from this directory here. And let me say I call Eclipse in this directory here. So when Eclipse opens, it doesn't initially know anything about this project. As I say, it's not an editor. It needs to be told about what the project is. It asks me about a place where I can store information. I'm going to accept the default and not want to be asked again. So once it has finally started, what I'm going to do is, so I see a window with multiple panels. So there's a panel on the left, on the center, on the right, and on the bottom. And I'm not going to use the one at the bottom right away, so let me minimize this here with this thing. And you will see that over here on the right, there's a new toolbar. I can click on this restore button and I get it back. So this is one way how I can use the screen space to maximum effect. And I will use this quite liberally, that I open and close. What is this here? This is not what I wanted. So I will use this so that I have as much space for the thing that I want to do at any given time, and only open these panels as I need them. So let me open a project here, for example. So I right-click into this Project Explorer window, okay, and I'm going to say new project, okay, and it is going to be a project that has its existing code and that has its own makefile. So I'm going to say yes here. And then it asks me for a location, and so let me browse this, and I need to browse my file system. So I start from my home directory. It's in Math 676, deal.II, examples, step 1. And I say, OK. I'm going to use the, actually, I think this part doesn't matter. You can choose any of these here. It will always work. OK, so it has opened a project called step 1. And if I expand this, you see in particular the step1.cc file. So if I double click on this, you get to see the source code here. The other thing that you see is over here in this window, there's an outline. Okay, so we've looked at step 1 in one of the previous classes, and it turned out to be a really simple program. So there's a function first grid, for example, and there's a function second grid, and then at the very bottom I have a function called main. Okay, These all show up over here in my outline. So this is a really convenient way to jump around in code. I can click, for example, on first grid, and it automatically jumps to this function in the editor. Another option to do this is if I type Ctrl-O, and it shows me an outline of this file. So in the beginning, at the top of this list, it shows me the header files, and then it shows the individual functions that are in there. And I can filter this. So for example, if I know that I want to go to main, let's say I'm in a file with a lot more functions, if I just started to type main, it filters this list by everything that matches the text that I just typed. So if you have hundreds of functions, but you know where you want to go, you just hit Ctrl-O, and then you start typing the function name. And when the list only contains one, you hit Enter. So one of the things that you see here is that there's a lot of marks here on the right where each one of these corresponds to an error. So for example, it says it doesn't know the word triangulation. It underlines hypershell boundary. And the reason for this is that it doesn't know where to find all of these symbols. So at the very top, for example, it underlines all of these header files, and it says it doesn't know them. So there are ways to deal with this. In particular, I can right-click on step 1 on the name of the project, and I can go down here to Properties. And so what I want to do is I want to teach it where to find these header files. So if you go to C++ General, to Paths and Symbols, okay. So for C++, I would like to add the path to the deal.II directory. And this is in my home directory. I installed it into the bin deal.II 8.0 pre include. So here is the header files that I included, or that I installed in one of the previous lectures. And so I'm going to add this for convenience to all languages, which doesn't matter for this particular project, but in general is helpful. And then I'm just going to say OK. And it's going to ask me whether it wants it should re-index everything. And I say yes, and in particular, it should always do this. So what's happening at the very bottom is it says it's indexing these everything that it just got to know of. And what you see is that it removed the squiggles under the name of the header files, okay, and the number of errors that are here has dramatically decreased. So there are still a few things that it doesn't know about. For example, it doesn't know where to find the class stdofstream here. That can be fixed. I don't want to do this here now, but about all of the other classes it has learned. So I would like to show you a little bit how to use this and how to use this in the editor. And one of the things that I would like to do for this first is that what you see here is a lot of comments in the code. The comments are essentially what we generate the tutorial documentation out of. So let me get rid of these comments. This is typically, let's say, if you want to continue developing a program out of one of the tutorial programs, the first thing you should do is strip out all the comments, because they pertain to the step 1 tutorial program and not to the program that you're going to develop out of it. So what we often see is that people start with all the comments that are in there that pertain to step 1, but then by the time they're done with the program, there is nothing, the comments don't apply anymore. So let me show you how to do this. So there's the command that we had yesterday, how to run this. So I say cmake -d deal2 dir equals home Bangerth bin deal2 8.0 pre, and then the sources are located here. Okay, so I showed you how you can run this program. So I say make, for example, it compiles this program, and then if I say make run, then it runs the program, and we end up with these two files, grid1.eps and grid2.eps. So if I type make strip comments, no, that was not the correct term. Comments. Here we go. So if I type make strip comments, then it will remove all of the comments from this program, and Eclipse automatically reloads the file, so you see that all of the comments are gone, and the only thing that's left is the actual code. So let me show you one thing. For example, let's say we didn't want to have a hypercube in this program, but that we wanted to use, let's say, a hyper-L. There's a function, you can look this up in the documentation in Grid Generator, that is called hyper-L. And so let me, for example, just start typing HYP, and then I hit Control Space. And it's going to show me all of the functions that it knows about that start with HYP. So for example, here's the function hyper-L. That's the one that I want. Okay, so I hit enter. I should say, if I had typed enough of the function name so that the function name is already unique, then it automatically completes this without even asking me. So what it shows me here is then that after selecting hyper-L, that this function takes 3 arguments: triangulation, a triangulation, a double, and another double. So I'm going to start typing tria. Okay, I have declared a variable of type triangulation above, and so I hit Control Space again, and it's going to offer me all of the possible expansions. The first one is typically the one that I want. Okay, so that's my first argument. Then I type comma, and it automatically highlights that I'm in the second argument, which is named left, and which is of type double. Okay, so I'm going to, let's say, I start, my left end of this L is 1, the right end is, for example, 4. Okay, and then I close the parentheses and hit semicolon. And you see how this is already much simpler than if I had to look up what is the exact argument list of this function and so on and so forth, or if I had to type triangulation, which is a word that I always mistype. All of these things are just really helpful. So let me save this one here. And then I go back to my command line window and type make run. So it compiles this object file now that it has been changed, and it executes it. And then I can call ocular and look at, so this was in my first grid function where I output the result into grid1.eps, so I can use ocular grid1.eps, and it shows me a mesh that is an L-shaped domain, which is one of the traditional test cases for PDEs because it has a re-entrant corner, and so the solution there is typically singular. So I hope this gives you a little bit of an idea of how to use things like Eclipse. Now, here's, I told you that I can rename variables. So let's say I wanted to rename this variable triangulation. You already see it highlighted. So let's say if I wanted to rename this variable to something else, then I would type Alt-Shift-R for rename, okay? And I would just change the name. Let's say I want to call it, I don't know, TR2. Not a good name. I like to spell out things. Let's say I want to call it, let's say I call it mesh. I think that's more descriptive. And then I hit enter, and you see that it has changed all of the occurrences of this variable name to mesh. What it didn't change is in this other function here, in the second grid function, the name remained the same because, like I said, it doesn't just replace text, it actually knows where the variable starts its life and where it ends its life. And so it is able to replace the names only where it is necessary. So all of these things are really convenient. If I go back here, let's say I wanted to show you the auto-completion in a little bit more detail. The triangulation class has a function with an awkward name that is called execute coarsening and refinement. So you already see. So I type mesh dot, and it already shows me all of the possible member functions that I can call there. If I just keep typing, then it reduces this list to everything that starts with an E. If I type another X, I already get everything that starts with EX. The function that I really want is execute coarsening and refinement, the second one on this list, and so I go down by 1, and then I'm going to Just hit enter, and it automatically completes it for me, and it shows me that there is no argument that is necessary. So I say close parentheses, semicolon, and I'm done with this. There's no possibility for typing mistakes and similar things. So this is essentially what you will deal with most of the time when you write code in Eclipse. This is the editing function. The things that I'm going to show you in the next lecture are what else you can do with this. So what are the things that you can do, let's say, that pertain to not just writing the code, but running the code, debugging the code, and so on and so forth. So I'll show you this in the next lecture. But for now, the takeaway message is really that Eclipse is not just an editor. It is an integrated development environment. And today, in 2013, you shouldn't be settling for an editor anymore. We're past the time of editors. We're at the time when integrated development environments are the standard, because we have computers where we have where these programs can be allowed to index everything in a project. So, I mean, I should say this. These tools didn't exist 20 years ago because the computers weren't big enough. If Eclipse runs, it uses several gigabytes of memory. But today we have this. 20 years ago we didn't. Today we have it. Use the information that these sort of tools can provide for you, because it's a lot easier to do it. There's so many tools, so much help that makes your life easier. So this is it for this lecture, and I'll come back and I'll show you a few examples of what else you can do with Eclipse to run and debug your code.